Oh. Hello. Time for compliments.
It's a bit different today. I'll show you.
4T. 4T.
Each finger is called T. So this is 4T.
7T. 70.
See? 70.
3T.
30.
2T.
20.
1T.
1T. 1T. 10. Have you got it?
1T. 2T. 3T. 4T. 5T. 6T. 70. 80. 90. 10T. 90. 8T. 70. 60. 5T. 4T. 3T. 2T. 1T. 0T. The complement in 10T of 6T is 40. And the complement in 10T of 5T is 5T. Easy. My grandfather's clock was too tall. No. My grandfather's clock was too tall for the shop, so it stood 90 years on the floor. It was taller by half than the old man's house, and it weighed not a penny weight more.
No, Fred, that's far too fast for a clock song.
You're not kidding.
Try this.
It was bought on the morn of the day that he was born. That's all right. It was always his treasure and pride, but it stopped short, never to go again when the old man died.
That was better. That's a kind of clock, really.
Well, when it beats out seconds, yes.
When it beats out anything, there's nothing special about a second. Why don't we make a clock?
Don't be silly.
I'm not. There must be something in here we can use.
Mary, you can't make a clock out of this old rubbish.
Why not? A clock's only a machine which takes time to do things regularly. Ah. Take this plumb line. Each swing takes a certain amount of time. So if we count each swing, we're counting lengths of time. 1, 2, 3, 4.
But you can't tell the time with that, can you?
No. Not unless you connect it to a dial of a clock or something. Look, I think we could make a clock with this. 1, 2, 3, 4.
Ah, yes. Each marble takes the same time to go down the slope.
Yes, well, the same length of time.
Yeah.
So, all we need is a supply of marbles up this end. 1, 2. With a counting device down here, with a mechanism that will release a marble up here when one arrives down there.
Oh, is that all? Anyway, I still don't see how that's a clock. A clock tells the time, doesn't it? All the time. Well, you can't just invent a clock like that.
I don't know. we are.
Mm.
The water comes out here.
Yeah.
And as it does, this float gets lower and lower, which pulls this string here, which turns that rod there, which moves this pointer hand here.
All right then, now make it.
I have.
Hey, that's great. How'd it work?
Well, just take this little stopper out here.
What's that?
It's just coloured water.
And the float's going down.
Yes.
Ah, look. The dial turns around. Hey, that's fantastic, that. Wait a minute. What I want to know is what happens when all the water runs out?
Okay, Fred. It's your turn to choose how the squares touch.
Right, and I choose sides. Sides touching. Hey, hang on. Let's make the rule that the sides have to touch along the whole length, like that, you see. Otherwise, you can make any number of shapes, you see.
All right. So you want whole sides touching, and you want to see all the patterns.
Patterns of 4, yes.
Okay. And that's the lot. All possible patterns with 4 squares, sides touching, I think.
Well, what about that one?
Oh. No, look, it's the same as that one.
If you turn it over, it's different.
Yeah.
Hey, what do you think would happen if we had 5 squares instead of 4?
That's a thought.